Welcome. In this series we are running an analysis of a simple lap joint and comparing the approaches in Abaqus CAE and 3D Experience. The analysis has now been set up, so in this video we will do the solving. So let's get started. In Abaqus CAE, to solve the model we need to define the job. We'll provide a suitable description and set the desired number of processes. Then we could submit that job. In the background, this would create an input file and then start the solver with that input file. Here though, we will just write out the input file. Before we solve this, we just want to compare the models and make sure there aren't any major differences. In 3D Experience, we don't need to create a job and link it back to the source model. The analysis case structure has already done that. Instead, we will do an update to make sure everything is synced, and then we can export the simulation. As we will see later, this isn't normally done. This wouldn't be a step on the standard process to run an analysis. We're just doing it here to generate an input file, which could be read into Abaqus CAE so that we can compare the files. Here we've opened the input files. We can clearly see that they are not going to be identical. However, the main thing we wish to check is what the default element type being used in both of these analyses are. This can have a significant effect on the results. Doing a search in the Abaqus CAE version, we see that there are C3D8Rs. These are the lower order bricks for the plates. In 3D Experience, we have C3D20 and C3D15 element types. These are higher order brick and wedge elements for the plates. Continuing in the 3D Experience exported input file, we also see that the tetrahedrals for the rivets are C3D10HS elements, while from Abaqus CAE, these are C3D10. The C3D10HS element type has an improved surface stress visualization and uses a hybrid formulation which is particularly suitable for metal plasticity. To ensure as compatible a simulation as possible, we will update the Abaqus CAE model to use higher order elements for the plates and to use the C3D10HS elements in the rivet. One thing to note, here we have gone to additional lengths to make sure the element type is the same and that the mesh density and step controls are the same between these models. In addition, the solver being used in 3D Experience is the same as that used by Abaqus CAE. This does not mean that we will get exactly the same answers between these models. We can see a difference in the meshes generated by default. For the plates in particular, Abaqus CAE has generated a hex-only swept mesh. However, this has forced an irregular pattern in the majority of the plate. In 3D Experience, the default mesh is very regular. However, if we remove the rivet from the display, we can see that a couple of wedge elements had to be used near the cutout. So the analysis won't be exactly the same because the mesh isn't the same. But they should be similar, assuming the mesh density for both is good. Solving in Abaqus CAE, we can submit the job we created earlier. Activating the monitor brings up a dialog where we can see the iteration calculation progress, and then the log, errors, warning, etc. are available in the tabs at the bottom section. In 3D Experience, we previously mentioned that we don't need to create a job. The analysis case is used instead. So we can just go to the Simulate tab and choose to do the various analysis and model checks. However, for this model, we will just simulate. This brings up a dialog where we can choose how many cores to run the analysis on. One key difference here is that in this case, the analysis has been done on a cloud 3D Experience role. This means that all the data is stored on the cloud, but it also allows for the solution to be run directly on cloud hardware. Here though, since this is a small model, we will run it local interactive. The dialog that comes up for this is generically similar to what's seen with Abaqus CAE. The different tabs provide different ways to view the analysis information. Iterations will show a very similar table showing the analysis progress. So here in this video we've seen that if you take the defaults, you may find some differences between Abaqus CAE and 3D Experience. This can be important to know if you are going to be doing comparisons. However, in both programs you have access to be able to specifically set options such as the element type used to ensure as close a match as needed. Although not normally a part of the normal 3D Experience solution process, for users familiar with the Abaqus keyword commands, the ability to export an Abaqus input file from 3D Experience can help point to situations where a different default is used. Thank you for your attention.